gamma 1 to 4 plus theta 3, 3, 1 belongs to CA. Let's see what will happen to the addition. Addition will be alpha plus gamma multiplied by 1 to 4 plus beta plus theta 3, 3, 1, which is can be written as I don't know, lambda 1 to 5 plus psi of 3, 3, 1, which belongs to CA because it's a linear combination of these color vectors, right? And if K belongs to R, then we have K alpha 1 to 4. I mean, we have actually this 1K, 2K, 4K multiplied by alpha plus beta multiplied by 3K, 3K, and K, which is, I can put the K out, alpha K, K alpha 1 to 4 plus K beta 3, 3, 1, which is K multiplied by alpha 1 to 4 plus K beta multiplied by 3, 3, 1. Again, it's a linear combination of columns, which means this belongs to CA. So, column vector is a column space. Column space has a very important usage. So remember, column space means that those linear combination of columns, and the reason that it is very important is this. Is very important because for the set of equation of ax plus b, ax is equal to b, which means we can write it in this form, right? I mean, sets of equation. We actually have A1 I mean, we can expand. We can expand. Can do the multiplication of this. It's like this column multiplied by this, then this column multiplied by this, and so on. So this means that the equation has an answer. We have an answer if look. We have answer, we have value for x1, x2 till xn, And if we have it, it means B is a linear combination of all these 8s, right? Isn't it true? If X has a number, then it means that we are just adding this column with this column, with this column, with the last column. Which means that they are linearly have been added. So B is a linear combination of them. What was the definition of column space? All the linear combinations. Which means that this B will be one of the elements of Cn. So if this B is one of the elements of Cn, then the equation has an answer. So as we have the column space, so in order our equation to have an answer, the constant, the B, should belong to the column answer. So we can start to define something which is a null space. And NA is the set of vector which is answer of AX is equal to 0. So a set of vectors which are answer of this. So NA is X which belongs to Rn, and AX is equal to 0. And we start by this example, which I want you to think about it, and we will solve it in the next class. Find the null space of 1, 2, 3, 4, 1, 1, 1, 1, 2, 3, 4, 5. Find the null space and tell me what does the null space represent. So it will be a set of vector. Can you tell me that which vector space it will belong to? I mean, it will belong to Rn, right? But here, what is n? I mean, you might remember it from the linear algebra. How many unknowns do we have? I mean, we have 4 rows and 3 columns. And it will be multiplied by x, right? What should be the size of x? 3 times 1. So it means we have 3 variables. So we look at the number of columns and we say, okay, the null space should be in R3. We will talk about it much later, that in a matrix of R n by n, we look at the null space in n. Okay? But we will come to that much later. Even if you didn't know that it will be in R3, if you start to find it, you will automatically find your answer into R3. But not only finding it, but I want you to tell me geometrically what does it represent. So think about it, and we will solve it next time in the class. Do you have any question? If you have no question, we may stop the camera and